So I'm Krish, pitching for ENBED. I'm here to pitch the idea of plug load management for smart buildings. So plug loads consume 50 to 30%, 30% to 50% of energy in buildings. So this is a fact. As an example, in California, the office plug loads alone consume 3 terawatt hours of energy every year. And it accounts for carbon emissions equivalent to 140,000 cars. So how are the plug loads being powered? They are powered through sockets. So I noticed in this room, at the base of the chair of each of you, there is one socket. So there are at least 130 plus sockets in this very room. What are the issues with the current sockets? For the residential side, there is no remote control possible at this point. Means you have to go manually and switch on, off. If you forget something, there is no way to access it remotely. There is no intelligent safety. Means the socket supply is up to 13 ampere in Singapore. So even if your device is consuming more than what it is supposed to consume, maybe a 1 ampere device consuming 5 amperes, the socket is going to simply supply. And the device might heat up, you have fire hazard later. No intelligent analytics for the energy bill. So how to get actionable intelligence by which you can change your consumption and reduce, be a greener citizen. So there is no way to do that. And energy is wasted by standby loads. It's a fact that even in NUS, there are thousands of things which are on right now, but the campus is not full. In commercial buildings, you have all the problems from the residential side, plus extra things. Like there is no plug load management system in a building management system. That means you have lighting, air conditioning, all these built into the building management system. Plug loads, even if they consume so much of energy, there is no method to manage it. There is no real-time asset management. That means when something is bought, after it is bought, you may not know where in the building the item is being used and how much it's using. There's no security. Anyone who has access to a building has access to the electrical grid of the building. Anyone can come in and plug in anything they want. So there is no access management. And no demand management. In Singapore, open electricity market is already launched, and there are many energy plants which can utilize the energy managing mechanisms. But for plug loads, there are no energy management mechanisms, so that can bring your cost down. Our solution for this is COS, Smart Electrical Outlet Socket Solution. How we do is we just attach a low-cost identifier to the plug load. Means we can make the existing plug loads smart. And we have our patent pending socket, which is a super smart socket. I would say maybe probably the smartest socket we know in the world. And it's interoperable with many other latest technologies, handled through an intelligent server unit. It's a very cheap server unit. You can install locally. So you don't really need internet to operate the sockets. But we also have a cloud server by which we make the solution scalable. And of course, we have mobile PC apps by which you can interact. So what are the values I'm proposing here? One is intelligent safety. So the values are for residential and commercial customer segments. Intelligent safety, demand side management. You can schedule your plug loads. Asset management, you can track your plug loads. With the click of a button, you can know all the plug loads connected, let's say in NUS campus. You can generate utilization reports. Maybe you bought something and it's being underutilized. Maybe you're spending money again and again to buy the same thing which no one is using. You can avoid that, optimize your purchase. Intelligent security. Even hot desking workspaces, any workspace, you can digitally authorize who can access the socket. When we look at the market, for Singapore market, we see around 300 million, and with the CAGR in the Asia-Pacific region of 12.4, so this is market research. And for the global market for connected devices, it's a very huge number. That's because this is not an isolated thing. It is an ecosystem of products which we are looking at, this being one of the key enabler. The revenue projections, looking only at the Housing and Development Board of Singapore, because they are the ones who build units, they want the units, units which they sell to be smart. And they are looking at products like this as ours. So up to 19 million in 5 years, that's our estimate based on realistic numbers. And we are looking at the service subscription. We are going to sell hardware plus the software corresponding to the operation. It's going to be a freemium service. And we would plan to achieve a market share of 6.4% in 5 years. Looking at the competitive analysis, technically we don't have any real competitor in Singapore, because in Singapore, yet the regulation is being formulated of using electronics inside the wall. You can still buy smart plugs, but smart plugs do not give you the physical safety, security which we can give. And they certainly do not actually identify what is a device, but we can. Because of unique features, which is plug load identification, electrical protection, asset management, power quality monitoring. This is a new thing which is coming up because of the photovoltaic penetration in Singapore. Beyond 2020, 1 gigawatt peak of solar energy is going to be present in Singapore. So you have to localize the power quality issues related to the loads. We can do that. You would have seen the tick rating used in Singapore. All this data is meant for a human being to read at this point. We can bring this data into an intelligent system through our socket. So you can say in your building, how many appliances are above 4 tick rating, or 4 or more tick rating. In the business model, we are planning to sell initially single gang and double gang sockets, corresponding freemium and premium services. And we are looking at Housing Development Board because they showed explicit interest in this product. And it's a scalable business. They build 14,000 units every year on an average. And the mechanism is going to be tender-based, the channel. As milestone, we need the next version of prototype is ongoing because of the GRIP, thanks to GRIP program. And for installation of COs in HDB unit, we are going to go ahead with a mock-up unit in HDB Woodlands area. They requested us so that they can do a public demonstration of how the socket works. We have to go through a certification, of course, because it's a highly regulated product. And we will do the test bedding with National University of Singapore. I already spoke to the facilities management of NUS, and they are willing to test out the product. So we are a team of 4 at this point, 2 PhDs from NUS, and we have an ex-VP from Motorola helping us with the strategy. He's currently not here. We have a professor, Sanjay Kumar Panda, who is our guiding that mentor for technology. And he's also a member of the working group of the Singapore Standards Council for the next generation of sockets in Singapore. And the ask, we need 400K, that is what we're asking. And we are looking at ecosystem development, certification, and small-scale manufacturing for test bedding. Thank you.
All right, thanks.
Please visit us at the booth so that we can show you the demo. Yeah.
Sure. Okay, thanks, Chris, for the interesting talk. Now we open the floor to questions.
Hello, hi, this is Karen. I saw you integrated a circuit board into the socket. Yeah. I wonder, because normally the socket, once it's built in, it never gets changed unless it's broken. And in this case, I know the circuit board has a lifetime. How long expect that going to last? The maintenance cost could be high.
Okay. There are no moving parts, so there is no wear and tear because of any mechanical operation. The lifetime, we have to still do the reliability test. But what we can provide is that we can provide a warranty service by which we'll replace damaged ones when you produce a large scale. So that's what I can tell you at this point. Yeah.
Next.
Thank you for the presentation. Could you sort of explain very, very starkly what exactly is the problem you're trying to solve and the value that can be unlocked if your product were to succeed, not just in Singapore, but globally? Because it didn't really come through from your presentation. I see bits and pieces of it, but I'm a layperson. I'm not the civil engineer.
Okay.
But if you could sort of put it very starkly, what is the problem and what value you can unlock?
Yeah. Everything around us are becoming smart, but our sockets are not smart enough to understand what you are connected so that we can manage the load. So managing the load is one is energy. You can turn off things which are not being used. At this point, there are thousands of things connected in NUS, just consuming energy, but of no use to anyone. So you can bring down the energy cost. That is one important value. Another is, if a device is consuming more current than it is supposed to, is overloaded, let's say, there is no way to detect overloading. In NUS, what they do is that every few months, there are people coming around, walking around, looking at the sockets, whether they are overloaded or not, so that they can minimize the fire hazard. And still we have fire hazards. So through our technology, you can know what is connected and whether it is overloaded or not, the socket. So we can almost remove all fire hazards because of overloading.
So I think one of the sweet spots is this. Think of the aging society, you go out from your HDB flat, you wasn't sure you turn off the oven or not. And this one you can remotely check, and in case you didn't turn off because you have a little bit of dementia, or your family can check for you, I think it will be very compelling as a value prop. Because I think a lot of times, even I myself, sometimes, did I turn off the thing? So I wasn't sure. Then I had to rush back and just check, triple check, right? So this one, you can look at your smartphone and check right away. I think it's quite easy, I think. I'm trying to find a sweet spot for you.
Yeah, thank you, sir.
Yeah, thanks, Provost, for sharing this sweet spot with the team.
Then I would suggest you take what Tech has mentioned as one sweet spot, sum up all the other sweet spots, and try and impute a commercial value to it. So how much would a person like me or a person, someone suffering from dementia, how much would, no, he wouldn't know, but how much is he prepared to pay for it? Sum it up. Because I think if you can do that and you put it very starkly, it would make it easier for, I suspect, investors and grant administrators to more easily grasp the commercial value of what you want, what you can do. Because if you can do this well, aging population, there's a pretty big pot of gold there.
Yeah, okay, thank you.
Hi, I was an energy consultant in Chicago, and one thing that we would find there is they had curtailment and demand shifting programs, and people would turn down the lights and the lifts and things. But what they complained about a lot of times was that they couldn't deal with the plug load. And what, is that what you're outlining here, is that they didn't have any way to track what was going on in the plug load and or control it?
Yes, you are right. So we can solve that problem.
Okay, because that was a case where they would pay real money to shift load, pay real money to cut back on load at certain times of the day, but they couldn't touch the plug load because it was just too complicated to have, like you said, people running around looking at every plugged-in device to try to check what was going on.
Yeah, you're exactly right. Singapore already has a demand response program. That means there is a financial scheme for paying back money for reducing your load when the utility asks you to. But there is no real infrastructure to do the demand response for large commercial buildings and especially plug loads. So through our technology, we can achieve that objective of responding to the demand response signal. Yeah.
Okay, we have time for last questions. Gentlemen, please.
Hi, I'm Li Wei from JCS Venture Lab. We invest, incubate, and also create deep head startup in Singapore. So I just did a very simple Google search, and Smart Plug seems that there's a lot of similar products in the market. And I think you should be familiar with them. They're used for smart homes, smart buildings. So what's the key difference in your technology compared with the existing technology offered in the market?
Yeah. So there are actually literally hundreds of smart plugs available there. What we have is, first of all, it's a smart socket which goes, the wall socket, it goes inside the wall. It is not something which you put on top of the existing socket. It gives physical security. That is one main point. Another thing is that the socket we have identifies exactly what is the appliance connected. Means if you connect your laptop to it, it will know it's your laptop, and what is the model of the laptop, what is the price, when it was manufactured, all the metadata related to the laptop. So this feature is absent from any of the smart plugs we know.
All right. Unfortunately, this is all the time we have. Thank you, Chris, for sharing his interesting technology and use case. Thank you.